Today we'll discuss about signal flow graph representation. Say we have one system described by some set of equations. Okay, then the representation which is obtained from the equations means which shows how signal flows in the system is called as signal flow graph representations. Okay, so next we'll see some terminologies related to signal flow graph. Okay, so say this is the signal flow graph shown in figure. Okay. First one is source node. Source node means it's a node having only one outgoing branches. So in this, I can say there are 1, 2, 3, 4, 5, 6 nodes, x naught to x5. So I can say that x naught is the source node because it has got only uh, outgoing branches. So next one is sync node. Sync node means it's a node having only incoming branches. So incoming branches means I can say xy is the only node which receives only the branches, incoming branches. So next one is chain node. Chain node means it's a node having both incoming and outgoing branches. Means between x0 and xy I can find some of the nodes like x0, x2, x3 and x4. So these will act as chain nodes. So next one is forward path. It's a path from input to output. So in this case I can say x0 is the input and xy is the output. So the path which travels from input to output is called as a forward path. So in this case first forward path would be x0, x1, x2, x3, x4, x5. That's as a straight line. So next one will be like x0, x1, x3, x4, x5. So third x0, x1, x3, x5. Last one is x0, x1, x2, x3 and x5. So we have got four forward paths. Next one is feedback loop. It's a path which originates from a particular node and terminating at the same node, traveling through at least one other node. Okay. For example, I can say x2, x3, x4, x2. So feedback loop is x2, x3, x4, x2, x2, x3, x4, then x2. So next one is self loop. A feedback loop consisting of only one node is called as self loop. In this case, I can say x3 is the self loop. X3 is the self loop because it starts and ends with the same node. So I can say it as a self loop. Next one is path gain. It is the product of branch gains while going through a forward path. Okay. So next one is non-touching loops. If there is no node common in between two or more loops, such loops are called as non-touching loops. So in figure A, I can find two non-touching loops. So L1 means I can say it's x1, x3. Then L2 means it's x1, x4. So these two are non-touching or two non-touching loops. Then in the second diagram, I can find three non-touching loops. It is x1, x2, x3, x4, then x5, x6. So next one is loop gain. It is a product of all the gains of the branches forming a loop is called as loop gain. So in this case, say this is L1. So with respect to L1, the loop gain will be G2 into minus H1. Then for second loop L2, it is minus 5. Okay. So next we have one formula called Mason's gain formula, using which we can find the overall transfer function for a given signal flow graph. So this is delta tk delta k divided by delta, where k is total number of forward paths, tk is gain of kth forward path, and delta is system determinant to be calculated. Okay, so delta how we'll write is 1 minus summation of all the loops plus uh, plus summation of gain into gain product of all the possible combinations of two non-touching loops, and it continues. Next we'll find the transfer function for this given signal flow graph.